Okay, for this problem, we have 2 degrees of freedom. If you look at the, consider a part of the water, then the water has 2 degrees of freedom. It can move in the x and it can move in the y. That means you need to have 2 accelerations in order to solve this without using forces. When the water is in free fall, it has an acceleration down, which is equal to gravity, and it has an acceleration in the x of 0. So here I've written the three, because the accelerations are constant, you can use the handy formulas. So here I've written the 3 equations: position equation, the top one, the velocity equation, and the another velocity equation in terms of position. So because you know the position of the water molecule at A and you know the position of the water molecule at B, but you don't really know the velocities other than the initial, I'm going to use the position equation, which is this top one. So we'll apply it in the x direction. The x location when the water molecule hits is equal to 35. It starts off at the origin, so it's 0. This is the horizontal initial velocity, and multiply by time. And then apply the same equation to the vertical. The y where it hits the building is negative 20 because it's below the origin. The initial is 0, the initial velocity, and 1/2 the acceleration. Since you're in feet, it's 32.2. And then I just applied the same equation in the z direction. You get 0 equals 0. All three, in the real world, all 3 equations should be written. Sometimes the z gives you information, sometimes it doesn't, like in this case. Okay, so now the big problem is trying to solve these equations, because you end up with a transcendental equation, something that has sines and cosines in it, and it's difficult to solve. So the real issue here is trying to solve it. Okay, I'm going to pause it and then pull up a couple of ways of solving it. Okay, here is a Mathematica program that will solve these equations. So here the equations are given by this right here. Notice that there's one equal sign here, which means I'm naming EQNS to be the following things. This is the curly brace means it's a set of things because you have more than one equation. And here are the equations that I copied over from the PDF file. So those are the equations, and you execute it, and it gives you these equations here. So you might want to just take a look at that and make sure that it's correct. And then what you do to solve them is you just say you want to solve the equations for the angle and the time, and here's what you get. You're going to end up with 4 solutions. If you notice, 2 of the solutions have negative time. Obviously, even though the math works, there's no way that physically you have a negative time. So you're going to ignore those, and you're going to pick these 2 solutions. One of them has a negative angle, if you notice, and that means it's pointed up from this, and the other one has a positive angle, which means it's pointed down. Now these angles are in radians, and so all I did was I copied and pasted down here, and I converted into degrees. So I converted the 2 angles into degrees. One angle is 11.55, the other one is a negative 71. The only other thing I'd like to point out is right here it's warning you that because you're using inexact arithmetic, anytime you put a decimal point in your formula, Mathematica assumes that you want it to use decimals rather than fractions, and so it's just telling you that because you did that, it may not be finding all of the answers. So anyway, this one's fairly simple. I'm going to pause it, and I'm going to open up another Mathematica program, and we'll talk a little bit about that. Okay, so here I'm doing essentially the same problem. Here I'm just kind of showing some ways of simplifying your typing. So here I'm going to say angle, A-N-G, is theta in degrees. So I want it to use degrees and not radians. The way you get the theta is you can use the palette. You might just type it out, theta, but anyway, so there's where I'm going to put it into degrees. I've also defined the CA to be the cosine and SA to be the sine, so I don't have as much typing. Here are exactly the same two equations. I'm just using that shorthand notation that I used up here. The other thing to notice is right here I'm using fractions rather than rather than a decimal. So 32.2 is equal to 322 divided by 10. So now it's going to use a fraction. So when you execute it, prints out your equations, and then I'm going to solve it. And then after I solve it, I want it to simplify it as much as possible. And again, I'm solving the equations for the angle theta and the value of time. Now you get something much more complicated than before. You get the values of time, and when you're solving for the angle, you get this wild looking thing, conditional expression. Basically, what happens is, if you notice right here, you're getting the inverse tangent, the arc tangent in this part of the equation. So it's inverse tangent of a fraction. You're going to have to use your calculator to get that number. But it says plus pi, and then it's any value of c right here, any value of c that's not 0, right? So this says c1 is not equal to 0. Basically, what it's doing is adding 2 pi, 360 degrees, to the solution. So here it's trying to give you all of the answers for the angle theta, and there's an infinite number of them. They're all 360 degrees apart. So what I'm showing here is that when you want all of the answers, you need to put it into fractions to get that. Okay, so let's scroll down. So that's why it looks so ugly. It's because it's giving you all of the answers. Most of the time you don't want that. So if that's the case, then again, all I'm doing now is putting in a decimal point, if you notice, and when I ask it to solve it again, it says, well, since I'm using decimals, I may not be giving you all the answers. But anyway, so here you go. If you notice, these are exactly the same answers that you had before, but this time the angles are in degrees rather than radians, and that's because I converted the A-N-G to equal radians above. But you get exactly the same answers. So here I'm just trying to demonstrate that when you want all of the answers, the answer will look ugly, but that's what this conditional expression is, and you're just adding 2 pi times a constant. So you're just adding 360, 360, 360, and you get all the answers. Okay, let me pause, and I'm going to show you how to do it with Excel. Okay, when I'm doing it with Excel, I'm going to show you how to guess at the answer until you get the right thing. Okay, so the first thing that you do is you solve the first equation for t, and so here that one's not too hard. You just do it. I think you can probably follow that along. And then on the second equation, what you're going to do is you're going to take this time, you're going to plug it into the t, and that'll get you an equation that has the angle in it. What I'm going to do is, rather than substituting the t in, I'm just going to solve the equation, and I just shove everything over to the right hand side, and so that all of this stuff here should equal 0. When I have the correct answer, this should equal 0. Okay, so what I'm going to do is I'm going to create a guess. So what I'm going to do is I'm going to create an angle in degrees, right? And so we'll say, all right, this will be a number. I'm going to change this number, but I'm going to be guessing at this. Because the Excel spreadsheet treats all of its angles as radians, what I'm going to do then is I'm going to calculate the number of radians here. So that'll equal whatever angle I have here. If it's converting into radians, I'm going to multiply it by pi and divide by 180. And that'll get me the number of radians for this. So you can see, 180 degrees, that should be equal to pi. 3.14, yeah, so it is. All right, so the next thing I'm going to do is I'm going to calculate the value of time. Okay, so the time is equal to, and that's on row number 2, the time is equal to 35 divided by parentheses 40 times the cosine of the angle in radians. So it'll be the cosine of this guy, and finish off the equation. So that'll be what time is if you have an angle of 0. That's what time is. Now what I'm going to do is I'm going to put in the second equation right here. So the second equation is going to, now that I have a value for time, this is going to equal 20 minus 40 times the sine of the angle. So this would be sine of the angle times time minus 16.1 times time squared. Okay, so that's the second equation. Now, if this number was 0, I'd have the correct answer. So now that you have this thing programmed, all you have to do is change this angle, and you're looking for the angle that's that makes the second equation equal to 0. Okay, so now I'm going to pause and I'm going to show you another simplification here. Okay, this is the spreadsheet that is posted for you to download. And essentially all I've done is I've taken this row that I showed you how to create, and I just copied it 2 more times. The top row here is going to be storing, because I have a terrible memory, this is going to be storing guesses that are that give you a second equation that's positive. This one will be the guess that I'm using now, and this one down here is when the second equation is equal to a negative number. Okay, so basically I start off, and at the beginning I just say, oh, I think everything is 0. If you notice, I have a positive here, so that's too high, so I'll put a 0 up there. Okay, so now I'm looking for a value that is negative, basically. So let's look for positive angles. So maybe the angle is 45. I don't know what it is, so I'm just going to guess 45. Notice that that's a negative number. So I say, okay, well, that's over here on the other side. That's too high. So I'm just going to put 45 in here. Now, what should I guess? Well, 0 is too positive. 45 is too negative. So you want something in between 0 and 45. So let's try, I don't know, 22. 22 gives you a negative. Okay, well then I'm going to put 22 down here. And now your correct answer ought to be between 0 and 22. So maybe make it half. Let's try 11. That one's not too bad, but it's a little too high, so we'll put that guy up here. So now your correct answer is between 11 and 22. Now if you look at these numbers, this is way off, -8. This one's pretty close. So the next guess, I think, is going to be closer to 11. So let's try 12. And that one's too negative. So what we'll do is we'll put that one down here. And so now the correct answer is somewhere between 11 and 12. So let's try 11 and a half. Pretty good. Okay, so that one is just a wee bit too high. So we'll put 11.5 here. And so now the correct answer is somewhere between 11.5 and 12. Let's try 11.55. That was pretty good. How about we say that that's close enough? So we'll say 11.55 is close enough. And that would be one of our answers. Now, down here, I've done basically the same thing. I've just copied the 3 rows from above. This time what I'm doing is I'm going to be looking for negative angles, because one of them, this 11.55, is positive angle, so that's pointed when he's pointing it down. The other one would be when he's pointing it up, and so he's kind of lobbing it in. So let's begin this thing by saying, well, maybe we'll try 90 degrees. Excuse me, it should be a -90, because I'm looking for negative angles. And that one is way too positive. So what I'll do is I'll put -90 up here. So I know it's between 0 and 90. So let's try negative 45, see how that works. That's a positive number, so we'll put this guy down here. Whoops, positive. I had them backwards, didn't I? So let me fix that. And minus 45. There we go. Okay, so minus 45 is 2 positive, negative 90 is 2 negative, so it's going to be between the two somewhere. So 40, about halfway. Let's try 65. Whoops, darn it, negative 65. And so that one's 2 positive, so we'll put that up here, minus 65. And so the correct answer is somewhere between minus 65 and minus 90. Let's see. It looks like it's going to be closer to the 90, so let's try negative 75. Right, that one's too negative, so we'll put it down here, negative 75. Okay, so the correct answer is between minus 65 and minus 75. So let's try negative, they're about the same magnitude. Oh, I screwed it up again, didn't I? Okay. So let's see, this guy's, no, that's right, yeah, minus 75, yep, okay. So it's between negative 65, negative 75. It looks like they're about the same magnitudes. So let's figure about halfway between them. So let's try negative 70. And that one's too much positive, so we'll say minus 70 goes up here. So the answer is between 70 and 75. Looks like it's closer to the 70, so let's try minus 72. That one's not too bad, so that would be minus 72 would go down here. And so it looks like it's between negative 70 and negative 72. Looks like it's closer to the 72, so we'll try negative 71.5. See how that works. And that one's, we'll go up here, minus 71.5. So it's going to be between negative 71.5 and negative 72, so minus 71.7, let's say. And that one's not too bad, so but it's positive, so negative 71.7. And so let's see, maybe negative 71.8, maybe 71.8. Not too bad. I think I'm going to call that quits. I'll say that's close enough, but you get the idea. You can keep going with this. Now, if you're clever and once you study numerical methods, what you'll do is you'll use the ratio between these guys, and you'll make a better guess at what the answer is based on which one is closest to. And if you did that, it would converge a lot faster. But anyway, so that's how you can guess at the answer. It's a numerical technique. Okay, that's it. I'll post this final solution so you'll know what the final guesses are. All right.